something that we will be consider the water table in our footings. Okay, before in Terzaghi, we did not consider the location of the water table. We just solve the given datas, the what do you call that, the given equations in the straight footing, square footing, and circular footing. But for today, we will be considering the location of the water table to be part of our solution. Okay, so the topic would be the modification of bearing capacity equations for water table. Okay, so equations in strip footing and square footing through the circular foundation in local shear. Okay, the strip footing there and the square foundation would in the general shear. Okay, give the ultimate bearing capacity based on the assumption that the water table is located below the foundation. Okay, so we will see this figure. Okay. So we can see na yung water table na, okay, ay pwedeng nasa case 1, okay, at the top of the footing, or at the uh, at the middle of the depth of the footing, okay? And the case 2 would be the groundwater level is at the bottom of the footing, okay? And there is also a case 3 there na it would be on, no? Nasa mismong baba ni footing, okay? So, however, if the water table there, no, is close to the foundation, no, yun yung sabi ko kanina, kapag sa case 3 yun, some modifications of the bearing capacity is equal, bearing capacity equation will be necessary negligible. Okay? So, minsan, hindi natin kinoconsider na kapag ganun. Okay? Bakit natin kino-consider si water table? Kasi si water table, it has an effect, okay? Meron siyang epekto sa ating soil na underlying natin ng ating foundation o ng ating footing. At the same time, it would also affect our footing. Okay? So for case 1, in the water table is located so that, okay, the depth of the footing is greater than 0 or mas malaki siya or mas mababa siya doon sa ground level, natural ground level, and it would be less than, or should I say, the depth 1, okay, is greater than 0 but less than its footing depth. Okay, so the factor Q there, or the bearing capacity equation, takes from this formula. Okay, the effective surcharge is equal to the depth 1 times the unit weight, okay, plus the depth 2 times the quantity gamma sat minus gamma water. Okay, gamma saturated minus the gamma of water. Okay, so the case 1 would be like this. Okay, nandito siya. If the depth 1 is greater than its natural grade line, so nasa baba siya ni natural grade line, and the depth of the footing, no, mas maliit siya kaysa kay the depth ng footing. Okay? So mas malalim si depth ni footing. Okay? Wherein the gamma sat there is the saturated unit weight of the soil, and the volume there is the unit weight of the water. Okay? Also, the value of y there, the gamma in the D1, in the last term of the equations has to be replaced by the gamma prime or the gamma saturated minus the gamma of water. So if you would notice for an example, the strip footing for Terzaghi, it would be the CNC plus Q and Q plus 0.5 gamma B and gamma. So the gamma there would be replaced by the gamma prime, which is equal to the gamma saturated minus the gamma of water. Okay? Ganun lang yon. So, papalitan natin si gamma doon sa last terms ni Terzaghi by gamma saturated minus the gamma of water. Okay? Naintindihan ba? Okay. Okay. So, um, okay, wala. Okay? So, Engineer Bakay, do you remember the equation for the Terzaghi in terms of square footing? Engineer Bakay, Mr. Bakay, are you there?
Ako po, sir.
Did you remember the equation for the square footing for Terzaghi?
Hindi po, sir.
Okay. How about you, Mr. Benkan?
Yes, sir.
What is the equation for that?
Square foundation, sir.
Yes po.
Sir, 1.3 CNC plus QMQ plus 0.4 YB NY.
Okay, the N gamma.
Uh,
For the last term, gamma, what is the substitute for that? What would be our equation for that for the last term?
that's
For the last term gamma, it would be interchanged by the gamma prime.
uh,
Am I right? Okay. For the gamma prime, it would be the gamma saturated minus the
mhm.
gamma water. Okay. I hope maintindihan nyo yun, guys. Thank you, Mr. Benkan. Okay.
Very
Going back. Okay. For the case 2, for water table located so that the depth, okay, yung depth mismo ni water table is should be greater or equal to the zero and should be less than or equal to its width of the footing. Therefore, the equation for that, the effective surcharge is equal to the gamma times the depth of the footing. Okay? Let's see the figure. Ito na nga po siya. Okay? The small letter D there is the depth of the footing up to the depth of the groundwater table, no? Below the depth of the footing. Okay? And then it should be greater to zero, which is to the natural grade line, okay? Or natural ground line. Okay? And then it should be less than the width of the footing, which is letter B. Okay? So in that case, the factor gamma there in the last term of the bearing capacity equation must be replaced by the factor gamma bar. Okay? So if case 2 would be happen, no? kapag nangyari yung case 2 na yon, no? The equation for the gamma for the last terms of those equations for strip footing, circular footing, and the square footing would be interchanged with the gamma prime or the gamma saturated minus gamma of water plus the depth nung ground nung ating water table from the depth from the bottom of the footing over the width of the footing times the gamma there or the unit weight minus the unit weight prime. Okay? For case 3, when the water table is located so that the depth of the groundwater table is less than or equal to the width of the water of the footing, the water will have no effect on the ultimate bearing capacity. Okay? Next one, the general bearing capacity equation. Okay, this would be pertaining to the equation of Meyers-Hoff. Okay, so for Terzaghi, meron siyang mga bearing capacity factors na NC, NQ, and gamma. And for Meyers-Hoff, meron na siyang mga different factors. Not only the bearing capacity factors, but also they added a different factors like shape factors, the depth factors, and also the inclination factors. Okay, we will understand that well as we go through our lesson. Okay, the ultimate bearing capacity equations for strip footing and square footing and the circular footing. Okay, or foundations, they do not address the case of rectangular foundations, wherein the B over L there is greater than 0 but less than 1. Okay? For the equation, do not take into the account of shearing resistance along its failure surface in soil above the bottom of the foundation. Okay? In addition, the load on the foundation may be inclined. Okay? So, meron na rin si inclination niya. To account for all the shortcomings, Meyers-Hoff in 1963, yan na si Meyers-Hoff, suggested the following form of the general bearing capacity equation. Okay? So this would be the equation of the general bearing capacity, wherein the ultimate bearing capacity is equal to the cohesion times the NC times FCS times FCD, FCI, plus Q, NQ, FQS, FQD, FQI, plus 1 half gamma B, N gamma, F gamma S, F gamma D, F gamma I. Okay? So, what are these terms na nandito kay Meyers-Hoff? Okay? For that equation, letter C there is the cohesion as usual. The Q there, it is the effective stress at the level of the bottom of our foundation. The gamma there in the last term would be the unit weight of the soil. Okay. The B there, it is the width of the foundation. For the circular again, it would be the diameter, okay, of the circular. FCS, FQS, and F gamma S, it is the shape factors. Okay? Meron na naman si shape factors niya. Okay? Si FCD, FQD, and F gamma D, it is the depth factors. Okay? And for the FCI, FQI, and FYI, okay, it would be the inclination or the load inclination factors. And again, NC, NQ, and N gamma, it would be the bearing capacity factors. Okay? So please remember this equation for general bearing capacity equation. So please remember that equation because I might be asking one of you to um, to try to solve the second problem later on. Okay. For the equations for determining the various factors given in that table or in that equation are described briefly in the section that follows, okay? Note that the original equation for ultimate bearing capacity is derived only for the plane stress case, okay? Or for an example for continuous foundations. So the shape, depth, and load inclination factors are empirical factors based on the experimental data. Okay. The bearing capacity factors. The basic nature of these failure soil suggested by Terzaghi now appears to have been borne out by laboratory. So the Vesis in 1973 trying to develop some formula for the NQ, NC, and gamma. Okay? Hindi siya nakontento kay Terzaghi because of his intelligent, no? Sinubukan niyang gumawa ng para sa kanya din. However, the angle aider, okay, shown in the figure closer to 45 plus internal friction divided by 2, okay, then to its internal friction or the friction angle, okay. In this change is accepted, the value of NC, NQ, and N gamma for a given soil friction angle will also change from those given. Okay? So, nandito na siya. Okay? For NQ, the equation for NQ would be tan squared times the quantity 45 plus friction angle over 2 times E pi tan phi. Okay? We would not be deriving this formula kasi napakahaba nito. Kapag sinolve natin, baka kulang pa ang ating buong time. Okay? Kasi sobrang haba talaga nito. Okay? And for NC, NQ is equal, for NC is equal to NQ minus 1 times cotangent phi. Okay? And for N gamma, it is equal to 2 times NQ plus 1 times tan phi. Okay? Okay, this would be the, again, the table for the bearing capacity factors. Okay? It would be the same lapag anong last time. Okay. This would be the factors. The formula for the factors, shape factors, and the inclination factors. Okay. So for these factors was recommended by De Beer in 1970. For the shape factors in relation to the cohesion, no, is equal to 1 plus the width of the footing times over its length or divided by its length times the quantity NQ over NC. Okay? And for the shape factor in relation to the surcharge or the effective stress is equal to 1 plus the width of the footing divided by length of the footing times the quantity tan phi. Okay? And for the gamma S naman, okay, it is equal to 1 minus 0.4 of the width of the footing divided by the length of the footing. Wherein the length there should be greater than B. Okay? So that the shape factor are empirical relation based on extensive laboratory tests. Okay? Okay lang po ba? Okay lang po ba? Okay. Okay. For the depth factors, it would be recommended again by Hansen in 1970. Okay. So the depth factor in relation to the cohesion, it is equal to 1 plus 0.4 times the depth of the footing over the width of the footing. Okay. And FQD, it is equal to 1 plus 2 tan phi times 1 minus sine phi squared times the depth of the footing over the width of the footing. And again, for the depth factors, okay, it would easy to to memorize that FYD, or the depth factor, in relation to the uh, what do you call that? In relation to the unit weight, or the length of the footing, which is equal to 1. Okay. But they are valid for the depth of the footing divided by the width of the footing must be less than or equal to 1. Okay? For the depth of embankment to foundation width ratio greater than the unity or greater than 1, the equation have to be modified to, okay, FCD, it is equal to 1 plus 0.4 tan inverse of DF over B. I think tan inverse there is not included. Okay? Hindi siya nakasali dyan. Okay? Kasi it would derive sa other formula na yan. Okay? So kapag ang FCD, I will be editing this later on, no? So si FCD is 1 plus 0.4 times DF over B. Please regard those tan inverse there. Okay? For FQD, 1 plus tan phi times 1 minus sine phi squared is equal to DF over B. So sometimes, no, ginagamit natin siya. Okay? And take note that FCD can be derived by using FQD, wherein FCD is equal to FQD minus the quantity, okay, 1 minus FQD divided by NC tan phi. Okay? We would be using that later. Okay. And also for FYD, it would be the same as equal to 1. Okay? Respectively, the factor tan inverse there, okay, yun na nga, sabi niya, DF over B should be in radians. Okay? Dapat naka-radians si tan inverse doon. Okay? For inclination, Meyerhoff and Hanna, and again, Meyerhoff in 1981 suggested for this following formula. Okay? For FCI is equal to FQI, it is also equal to 1 minus the beta angle divided by 90 degrees, the quantity squared. Okay? For FYI, okay, it is equal to 1 minus beta times the phi, okay, the I divided by the phi, okay, and quantity squared. Okay, the beta there, it is the inclination of the load, okay, on the foundation with respect to the vertical. Okay. Okay. Did you uh na ganun niyo po ba yung mga formulas natin? What do you call that? Na sink in po ba yung mga formula sa atin, or um, balikan ulit natin bago we will go to the example? Do you like to discuss again, or we will continue with the example number 1? Hello? We will continue po ba? Continue natin?
Yes, sir.
Okay. The first problem would be the same problem, would be the first problem on our bearing capacity, the Terzaghi bearing capacity. Okay? Miss Pintukan, are you there? Can you read the problem number 1?
Yes, sir.
Okay.
A square foundation is 2 meters by 2 meters in plan. The soil supporting the foundation has a friction angle of Phi prime is equal to 25 degree and C is equal to 20 kilonewtons per meter square. The unit weight of soil gamma is 16.5 kilonewton per meter cube. Determine the allowable gross load on the foundation with a factor of safety of 3. Assume that the depth of the foundation DF is 1.5 meters and that general shear failure occurs in the soil.
Okay, thank you, Miss Pintukan. Okay, so for this problem, it is an square, okay? And the given data, nandyan na po. Andyan na si friction angle, which is 25. Andyan na din si cohesion. Andyan na din si unit weight. And andyan na din si factor of safety. And also the depth of our footing. Okay? So we are our task is to find the allowable gross load. Okay? And we will be using the general formula for the for this problem. The general failure. Okay? The general shear failure. Okay? Yung kanina. Okay? Miss Flores, did you remember the formula? Miss Flores?
Sir?
Maalala mo po ba yung formula na pinagdi-discuss natin kanina?
Sir, yung general formula po?
Yes po.
Sir, yung general bearing capacity formula equation po ba?
Oo, yung nandito sa presentation na to.
Um, Sir, ultimate effective stress is equal to cohesion times times bearing capacity by times bearing capacity times shape
Ah,
factor
okay.
shape
Miss Flores,
factor
wag mo nang sabihin yung mga ganun niya, yung mga tawag dito, terms niya. Just tell me yung NC, NQ, FC, FD, like that.
okay sir
Ah,
QU is equal to C prime times NCF times FCS times FCD times FCI plus Q and Q times FQS times FQD FQI plus 1/2 YBNY times FYS times FYD times FYI, sir.
Okay, thank you, Miss Flores. So, my dear students, just remember, okay, para hindi nyo makalimutan yung the general bearing capacity equation, okay, just include yung the shape factors or the factors, okay, the depth factors, the shape factors, and the inclination, okay. Uh, i-add nyo lang siya for may three terms yun, okay? For the first term, okay, may add ka lang na tatlo lang din, okay? It would be the shape factor, the depth factor, and the inclination. Since cohesion, yung kanyang yung kalakip na kasama, okay, it would be FCS, FCD, okay, and FCI. Okay? Dapat meron si C doon and then merong S, D, and I. Okay? Likewise, okay, for the second term, Q naman siya. Okay? Ang idadagdag nyo lang is FQS, FQD, FQI. And for the last term, it is the gamma or the unit weight yung nandoon sa term na yon. It would be F gamma S, F gamma D, and F gamma I. Okay? Don't worry that F gamma D is always what? Gamma D ba yun or gamma I? Okay. It is gamma D. Okay? Okay. So we will go now to the solution for this. Okay. So this is the formula. Okay. The F, no? I would not be isa-isahin pang ganun kasi uh, tumatakbo ang oras natin. Okay. So this would the equations that was said by Engineer Flores. Okay. The cohesion there, okay, for FCI, okay, FQI and F gamma I, 1 siya. Okay. Bakit po siya 1? Yun yung tanong ko. Bakit siya 1? Okay. Miss Lapagan, bakit siya 1? Yung kanyang FCI, FQI, and F gamma I. Miss Lapagan. Nandito po ba si Miss Lapagan?
Sir, di ko po alam.
Okay, thank you. Ganda yan kasi sinasabi mo lang yung opinion mo. Okay? And it is nice that you are answering a tawag dito, a kung ano yung talagang gusto mong sabihin. Okay? Thank you, Miss Lapagan. How about you, Mr. Reyes? Why that FCI, FQI, and F gamma I, it is equal to 1? Ano idea? Okay. So, I know na no idea. From the group, you have an idea? May idea po ba ang iba sa inyo kung bakit natin na-derive si FCI, FQI, at F gamma I na 1? Meron po ba sa group or none? Meron po ba? Wala. Okay. So, kaya nakuha si FCI, FQI, and F gamma I because ano yung I dyan? It is the inclination, di ba? Am I right? It is the inclination. It is the inclination factor. Okay? Kapag ganyan, na inclination na if the problem doesn't stated kung what the degree or what degree inclination, okay, yung binigay niya, it would be notified as 1. Okay? 1 na siya kapag wala namang sinabi na degree of inclination. Okay? Pero kapag sinabi na may degree of inclination, then use the formula, okay, na binigay natin kanina. Okay? I hope na ma-absorb nyo yun. Okay? Okay lang po ba? Okay lang po
Yes, sir.
ba? Okay.
Yes, sir.
Thank you. So, go on. Okay? The NC there. Okay? Since the internal friction or the friction angle would be the 25 degrees, so the following bearing capacity factors are NC is equal to 20.72, NQ is 10.66, and N gamma is 10.88. So let's substitute. Okay. For FCS, the equation is 1 plus this one. 1 plus the width of the footing divided by the length of the footing times NC over NQ. Okay? Just input all those given datas. Okay? You would be derived 1.514. Okay? Na-derive nyo na si 1.514. Okay? There is no unit there kasi makakancel naman siya. Okay? For FQS, okay, it would be 1 plus the width of the footing divided by the length of the footing times tangent inverse or tangent phi prime, okay? Or the friction angle, okay? And then again, just input those given datas, you would derive 1.466. Okay, nasundan po ba 'yun? Nasundan po ba?
Yes, sir.
Okay. So, yan, yung mga formulas naman dyan, kapag meron naman na kayong nailatag na formulas, then go with the flow na. Just input all those given datas available. Okay? And for gamma S, okay, 1 minus 0.4 times the quantity, the width of the footing divided by the length of the footing. Again, just input all those given datas, then you would derive 0.6. Okay? The next one is to compute its FCD. Okay? Then FCD can be computed as the use of FQD. Okay? So FCD is equal to FQD, no? Times the quantity 1 minus FQD divided by NC tan of friction angle. Okay? So we cannot solve that yet, okay? Because FCD is unknown pa, no? Kailangan natin pang kunin si FCD. Okay? ICFQD, should I say. Okay? Therefore, FQD, it is equal to 1 plus tan phi, okay? Times 1 minus sine phi, okay? Squared of that quantity times the depth of the footing divided the width of the footing. Okay? Then just input all those datas and it is equal to 1.233. Okay? Therefore, substituting the value of FQD to the in getting the FCD, okay? So 1.233 minus the quantity 1 minus 1.223 divided by 20.72 times tan 25, it is equal to 1.257. Okay? And then again, the FYD ang napakahirap na isipin, it is equal to 1. Okay? Then FCI and FQI and F gamma I, it is also equal to 1. Okay? Because the inclination is not stated in the problem. Okay? So, by using the formula, QU is equal to CNC, FCD, FCS, FQI, FCI plus QNQ, FQI, QS, FQD, FQI plus 0.5, gamma B, and gamma F, FS, F gamma S, FYD, and F gamma I. Okay? So therefore, Q is equal to 20 times the 20.72 times 1.514, okay, times 1.257, okay. Hindi na natin sinama si FCI because 1 naman din ang kanyang value, okay, plus 1.5 times 16.5, the effective stress, which is the depth of the footing, okay, times the unit weight, okay, times 10.66 times FQS, which is 1.466, 1.233, okay? Hindi na natin sinanli si FQI because it is 1, okay? Plus 0.5, okay? Times 16.5, okay? Times 2, times 10.88, times 0.6, times 1, okay? Therefore, yung makukuha natin value, it is equal to 1,373.26. Okay? Baka may magtatanong sa inyo, Sir, bakit hindi natin ginamit si gamma doon sa last term na pinalitan kay gamma prime na gamma sat minus gamma only water? Okay? My dear students, hindi naman stated dito sa problem kung saturated ba siya or hindi. Okay? Basta ang binigay lang is gamma lang or the unit weight. Okay? So, kapag ganyan lang, giniven niya is gamma lang siya or the unit weight lang siya, hindi niya sinabi kung saturated ba siya or what, no? Hindi mo na kailangang i-times na, ay minus ng 9.81 as the gamma of water. Okay? So, yan na yung magiging gamma ni prime. Okay? Naintindihan po ba yun? Okay. Therefore, no, Q allowable would be the QU, okay, the ultimate bearing capacity divided by the factor of safety, which is 3. Okay. Then dividing that, no, you would derive the answer to 457.753. Okay? Kilonewton per meter squared. Okay? Okay lang po ba? Okay. Mr. Figuerero, that one, Noel Frederick. This Q allowable, ito na po ba yung ating hinahanap? Ito na po ba yung ating hinahanap? Mr. Noel, are you there? Mr. Noel?
Sir, hindi pa po ata. Or hindi pa po ata, sir.
Okay, hindi po po ata. So may kalakip na ata. Okay, you are not sure. Okay, thank you, Mr. Noel. Miss Addon. Ito na po ba yung ating hinahanap na load? Allowable load?
Hindi pa po, sir.
Okay. Paano mo nasabing hindi ito yung ating hinahanap? Because of the word? Malala mo? Miss Adun?
Hindi po, sir.
Okay. Hindi pa kasi siya kasi take note, the unit for that Q allowable is kilonewton per meter square, okay? And then we are just to find the load, allowable load. So ang magiging unit weight lang ni load, it is the kilonewton, okay? So therefore, hindi ito yung ating hanapin, okay? So take note na kapag Q allowable, kilonewton or meter squared yan. Okay? Kasi hindi naman magbabago yung kanyang unit, hindi mo naman makakancel yung kanyang meter square because the factor of safety, which is there is no unit weight or there is no unit for that. Okay? So therefore, no, hindi pa ito yung ating hanapin. So, paano natin hanapin si allowable load? Anyone from the group?
Times sa area, sir. Times sa area, sir.
Okay, thank you. So that's right. So ita-times natin si Q allowable, okay, kay area para matanggal natin yung kanyang meter squared. Okay? So Q allowable, it times area would be 753 times the area, which is 2 times 2, which is 4. Okay? And therefore, ang makukuha nyo dyan ay 1,831.012 kilonewton. Okay? Nasundan po ba yun?
Sir, nawala po yung presentation.
Yes, sir.
Ay, nawala. Sorry. Nag-exit pala siya. Sorry, napindot ko. Ano, meron na po? Meron na po?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. So, andyan na, nakuha na natin si Q load. Okay? The allowable load na ating hanapin. Okay? And then, mamaya, may magtatanong sa inyo. Kagaya sa other set kahapon na, Sir, nagkataon lang po ba na yung ating QU, okay? At pinag-add natin kay Q allowable, no? Ay makukuha si Q, no? Si Q allowable. Okay? Okay. Sir, yun yung tanong nila, no? Na is just an instance or coincidence na na na-derive din yung Q using the QU plus Q allowable. Okay? Take note that it would be a possible, no? Possible na nangyayari din yun like this problem, okay? Then take note din na kapag yun ang ginamit ninyo, oh, tama yung magiging yung inyong coefficients, okay? Yung 183, 1.012. But your unit, yun na yung magkakatalo-talo kayo. Okay? Kasi yung unit, no? If you would add kilonewton per meter square, yun lang yung maiiwan. And you did not apply the area. Okay? Nawala tuloy si area na kailangan, yun yung kailangan mong gamitin. Okay? Therefore, kapag yan yung sagot mo, kilonewton per meter square, okay? And then, you would be deriving a wrong answer. Okay? Kasi, baka mangyari lang, okay? Baka mangyari lang at maisipan yan ng mga examiners ninyo in the future, no? In your future board examination, na, for instance, for letter A, no? Ang ilalagay nila is 1831.012 kilonewton per meter square. Okay? Take note that the question is to find the allowable load. Okay? Kilonewton per meter square. Okay? Ay, kilonewton lang. Pero ang nasa problem, letter A, it is a kilonewton per meter square. Letter B, it is a kilonewton per meter square. Okay? But yung coefficients ni letter A at letter B nilagay sa letter C at letter D, which is kilonewton lang. Okay? Baka yung iba sa inyo nakalimutan kung ano na ba yung unit weight, okay, ay yung kanyang unit, no? Kapag allowable load, no? Baka maisipang gamitin yung letter A, no? Na 1831.012 kilonewton. Okay? Kilonewton per meter squared, okay, should I say. Okay? Na kailangan ang sagot nyo doon, letter C. So, ingat-ingat kayo dyan. Okay? Sayang ang isang puntos. Okay? Knowing that hydrogeo, napakadali din siyang isolve during the board examination. Ito ata yung araw na hindi ka makapaniwala na ang bilis mo na palang natapos yung exam na ito. Okay? So, take note of that. No? Ingat-ingatan nyo yung mga pinagsosolve ninyo. Okay? Okay lang ba? Okay lang po ba?
Yes, sir.
Okay, ganun kaya during your review, no, kailangan wag tayo isa-isip lahat ng mga kailangang concepts na gagamitin ninyo. Okay? Don't just rely on those formulas. Kasi ang formulas, pwedeng mag-iba-iba yan. Okay? Okay, naintindihan na po ba itong problem number 1? Naintindihan na po ba? Okay. Let's go now to the number 2. Okay. I will just upload. I think in-upload ko na yung presentation, but this solution, hindi ko pa na-upload. Okay. But I will be uploading later on para magawa ninyo yung inyong learning task. Okay. Andito na po ba si Dan series natin? Mr. Pamitan?
Sir.
Please read the number 2 problem.
A square foundation has to be constructed as shown in figure 3.7. Assume that gamma is equal to 16.5 kilonewton per cubic meter. Gamma saturated is equal to 18.55 kilonewton per cubic meter. Sir, ano po, hindi ko makita.
Sorry. Sige.
And,
Kita mo na?
yes, sir. Yes, sir.
Okay.
Okay po. Saan na yun?
Dito sa friction angle.
Ayun, friction angle is equal to 34 degrees. DF is equal to 1.22 meter and D1 is equal to 0.61 meters. The gross allowable load with factor of safety of the tree is 667.2 kilonewton. Determine the size of the
Footing.
footing.
Okay.
Use equation 3.19.
Okay. So for this one, okay, thank you, Mr. Pamitan. Okay. For this one, we are we are obliged to design for a specific footing. Okay. So we would determine the size of its footing. Okay. So binigay naman na yung data niya, okay? Yung kanyang Q allowable, okay? Yung kanyang the depth of the footing, the saturated weight, okay? The gamma there is also 16.5, and the depth of D1, which is 0.61, okay? And the gross allowable load, which is 667.2 kilonewton, which with its factor of safety 3. Okay? So, let's check. Okay. 34 degrees ang kanilang friction angle. Okay. I will be... Wait. Ilagay ko lang yung kanyang ganun. Then, you try to answer this one. Okay. Sige, try nyo to muna. Kita nyo po ba yung problem?
Yes, sir.
Okay, try nyo muna itong isolve. Para it also likewise to have your break. No? Break din natin to. So, we would back at exactly 9:15. Okay? And then later on, isolve lang natin to. Then, let's move to the, what do you call that? No, gawin nyo na yung inyong learning task later on. Okay? So, yun lang. I will be
Okay, just do whatever you may yung maalala with this one. Then we will check and I will be asking one of you to present your solution later on. Okay? So, yun lang. Gawin nyo kung ano yung pagkakaintindi nyo. Okay, with the formulas. I know, and I hope also na meron sa inyo yung presentation na ito, okay, for you to determine what formulas to be being used. Okay? So, if you have a questions, just sabihin nyo lang sa akin. Okay? Nandito naman lang ako. Okay? Okay lang po ba? Okay, sige. Gawin nyo na muna.